All right, 10-4, we're writing a polynomial function. We're using the given information to write the polynomial function, and then you're sketching the graph. So it says on number 1, a quartic equation, remember that's x to the 4th, has a double root at 0, and then has roots at -3 and 5. It also gives us a point on our graph, which is 132. Okay, first thing we're going to create our function, we're going to have f of x equals a. We're not going to know a, which is our coefficient in front. And then we're going to use the roots in order to find our factors, which will form our function. So if I have a root at 0, we know that factor is x, but it's a double root, which means it would be x squared. And then I have a root at -3. Remember, when we've been finding the roots, we're setting our factors equal to 0 to solve for x. So if I have a root at -3, that would be x plus 3. And then a root at 5 would be x minus 5, because you're setting those equal to 0 to find roots. Okay, so there's my function, but I need to know a in order to figure out the direction of my graph. So I'm going to use this point that we were given. So x is 1, y is 32. We're going to plug in. F of x is the same thing as y. So that's 32 equals a. X is 1. One squared, we get 1. 1 plus 3, we get 4. 1 minus 5, we get -4. So we should end up with 32 equals, multiplying all of this together, we get -16a. So then we would divide by -16, and a would equal -2. Okay, so we have f of x equals a is -2. And then we have x squared, x plus 3, x minus 5. So there's our function. Now I'm going to write my roots down, so that'll help me with my graph. I have a double root at 0, a root at -3, and 5. So I have 4 total, which is quartic x to the 4th. Our a was -2, so a negative quartic graph will open down. So overall, that's what our graph should look like. So I have a root at -3, 0, and +5. So on the very far left side, I need to start down because it needs to open down. And I have a double root at 0. So we're going through the -3. Once we get to the 0 point, I need to curve it back to make it look like a parabola since it's a double root. So it should look like an M. You can check, remember we're not using a Y scale, but you can check your point to make sure it's in the correct quadrant. So 132, that point would be up here. So notice it is part of your graph, so make sure that it's in the correct quadrant by checking your point. Okay, number 2, we have a cubic equation with a double root at -2 and a root at 1. And it contains the point -1, 6. So we'll have f of x equals a. We will never know a. We have a double root at -2, which would mean x plus 2 squared, and then a root at 1, so x minus 1. Plugging in my point so that way I can find a, that will help me with my direction of my graph. So I'm going to have 6 equals a. And then we have -1 plus 2 squared, and -1 minus 1. So 6 equals a. Inside parentheses here, we end up with a 1, but we have to square it, so that's 1. And then we have -2. So multiplying those together, we end up with -2a on that right side. So when we divide by -2, we find a to be -3. So when you're writing your function, we're placing a with -3. And then we had a double root at -2, so x plus 2 squared. And then x minus 1 for your roots, I have a double root at -2 and a root at 1. So I have a cubic, and our A was negative, which means it should be decreasing from left to right. So double root at -2 and a root at 1. I need to start at the top on the far left. It's double root at -2, so it should curve and then curve back to go straight through your single root at 1. Alright, let's take a look at 3. So we have a cubic equation with roots at -3, 3, and 1, and it contains the point -1, 8. Alright, so I have a root at -3, which would be x plus 3 for the factor, a root at 3, which would be x minus 3 for the factor, and then a root at 1, which would be x minus 1 for the factor. So I'm going to use the point in order to find A, so I know the direction of the graph. So y is 8, x is -1, so we end up with a 2, and then -4, and -2. So multiplying those together, 2 times -4 is -8 times a -2, which will give you a positive 16. And then when you divide, you get your A to equal a half. So writing your function, f of x equals a half, x plus 3, x minus 3, and x minus 1. So our roots are -3, 3, and 1. So we have 3 of them, so it's cubic. The A was positive, so it should be increasing from left to right. So I have a root at -3, +1, and +3. So on the far left, I'm going to start below because it should be increasing from left to right. I'm going straight through each one because I don't have a double or triple root. Alright, last one. We have a quartic equation, so x to the 4th, which means 4 roots, triple root at 2, and a root at 4. It contains the point 5, -27. A triple root at 2, so you're going to have x minus 2, but then you're going to have to cube it. And then a root at 4 would be x minus 4. So y is -27, x is 5. So we end up getting a 3 here, but we have to cube it. 3 times 3 is 9, times 3 we get 27, and then 5 minus 4 we get 1. So we should get A equals -1. Since it's -1, all I really have to write in front is a negative, but you could also write -1. Roots, a triple root at 2, and then a root at 4. So it's quartic. It's a negative for your A, so it should be opening down. So triple root at 2, and then a root at 4. It should be opening down, so start below. At your triple root, you need to indent it like your cubic. You should be able to look at the graph and determine it's cubic, or a double would be parabola. Okay, again, I didn't do it on the other ones, but you could always check this and make sure it's in the correct quadrant. So 5 would be -27, which would be down here. Okay, so that's a way that you can also check the direction of your graph.